So let's look at some of the issues that make the climate change and human health a bit more complicated. So there is a concept called climate gap, which is similar to the disparities that we talked about, which obviously creates social inequities and that affects the health outcome, right? As is always the case. So economic impact of historical global warming. If you take from 1961 to 2010, change in percentage GDP per capita, you can see that global south has largely experienced negative growth in personal GDP. Obviously, climate impacts have had a huge negative impact in terms of displacements, employment, agricultural productivity loss, extreme events, health outcomes, productivity loss, and so on and so forth. And of course, the rich countries have had positive outcome, as one would expect. And even if you look at a more recent period from 91 to 2010, the negative impacts still persist in the global south, and positive impacts still continue to occur in rich countries, the global north. Right? These are the so-called climate gap. Not just impacts, but also the socioeconomics of the most vulnerable and the global south. Okay, the health cause, since we are talking about climate change and health here, you can think of in terms of climate change and air pollution. These are estimates from the World Environmental Health Day put out by our health and environment on WordPress. So the impact of climate change on lives lost and ill health in OECD countries, which is Organization of Economically Cooperating and Organization of Economical Cooperation and Development, and China and India. It's 3.5 trillion annually. That's the cost of impact of climate change just on lives lost and in ill health. Okay, there are very many details as to how they are calculated. Nonetheless, you can also go deeper and look at costs of childhood asthma, childhood cancer, childhood lead exposure, childhood neurobehavioral disorders, and they are all related to environmental exposures just in California. That's $254 million every year. This is a rich country, progressive state, lots of strict regulations of fuel efficiency, air quality, water quality, and so on, and yet that's the cost. You can imagine how much it would be, how worse it would be in the global south. Okay, so these are the issues that one has to deal with when you want to consider interventions for climate change. It could be through mitigation and adaptation. So here is one chart from this site that I picked up, looking at policy and systems change, mitigation, climate education, geoengineering, which we haven't talked about. It's basically methods by which you try to reflect sunlight back to space, like sprinkling dust in the upper atmosphere which reflects sunlight. The problem, of course, is you may reduce incoming energy, but you don't reduce the CO2 that we are emitting. So in fact, it may be a bad idea to do that. We learned that from what happens during volcanoes. During volcanic eruptions, volcanoes put certain ash and sulfates and so on in the upper atmosphere, which reduce the incoming sunlight, like it happened in the 1800s, which led to Edvard Munch to draw his famous painting, The Scream, which shows the colorful sunset in the background, right? Adaptation measures. Remember, mitigation is reducing our impact on climate. Adaptation is adjusting to changes that are already happening. Disaster risk reduction and disaster recovery. So they affect climate behavior, There are other environmental factors, of course. They want to reduce greenhouse gas emissions in the first place, reduce global climate impacts, and hence also reduce local impacts and various intermediate factors of water pollution, air pollution, food production, food quality, water quality, climate change, and health inequities to be reduced, and also affect positively or reduce disability and death and health and social costs of climate change impact on human health. Okay, so these are of course easy to say, but at what scale does it happen and who does it? For example, right now everybody is burning fossil fuels, right? Rich people are burning it more, but poor people want to burn more by getting richer. So India and China are growing economically and they want to continue to do that. You can't blame them. They want to raise the standards of living for their people, which necessarily means consuming more meat, driving more, living in individual houses, increasing energy consumption, and so on, right? Carbon footprints continue to go up. So the direct effects of fossil fuels on human health basically come from not only mobile engines, transportation, and so on, but also cooking and shelter, so heating and cooling of the buildings. So in-house air quality gets affected, which affects human health. Urban air quality is affected, which affects human health. And we increase greenhouse gases and planetary health is affected, which in turn affects our health as well. And there are other human activities like peatland fires, which affects landscape air quality, which affects our health. We also do mining of gas and oil, which affects land use change. All the fracking that has become more and more prevalent now in the US, for example, is contaminating air, water, increasing the use of water, and so on. So that also affects greenhouse gases and planetary health. So there are obviously many direct impacts of fossil fuel consumption on human health, which is related to the overall human impact on our own health. Okay, and the new concept now is something called cascading impact. This is coming out of the Intergovernmental Panel on Climate Change based on a lot of the research by the community. So IPCC basically synthesizes community research, and they are taking climate impacts, climate events like weather, with natural hazards, of course, anthropogenic climate change, and abrupt changes and tipping points. We haven't talked about that again, so let's not go too much into that. So there are climatic drivers, which are singular, compound, and sequential. They add to extreme hazards. There is the vulnerability related to socio-economic processes like risk management, climate resilient pathways, transformative governance, adaptation mitigation. These are the non-climatic drivers. Okay, risk management. For example, what would a community do against sea level rise, about extreme events, about finding climate resilient pathways to infrastructure, to agriculture, to energy production, to people's livelihoods, and so on and so forth. Transformative governance, it just is a word, but it does mean how to manage the climate change as a part of the socio-economic activity. Right? Remember, we talked about climate pollution and carbon-based economic impacts on human health. Those are kind of in terms of reducing our own impacts. Adaptation and mitigation, we have already talked about multiple times. So these things affect vulnerability. Hopefully the effort is to reduce vulnerability, and the non-climatic drivers can also change your exposure. So climate resilient pathways should reduce your exposure. So risk is basically exposure times vulnerability. Okay, so there is a hydroclimatic hazard like extreme rainfall, extreme snowfall, flood, drought, whatever. And then your vulnerability depends on your education, your income, your habitat, your natural defenses like forests and so on. And the risk is basically how much you are liable to lose in terms of life and property. Okay, so they are not independent, they together form what is now called compound risk. Okay, there are also emissions involved from land and ocean use change, but even though it's a schematic, it begins to give you metrics to define compound risk from the various factors. So you cannot just worry about climate, you cannot just worry about socioeconomic processes, you have to worry about how the vulnerability at a community level and individual level begin to bring together these multiple events to give you a compound risk. I know it's a bit vague, but these are real concepts now under IPCC, and hopefully they lead to better observations of climate change, socioeconomics, and better quantification of compound risks, because then you can set up institutional structures to reduce those risks and manage those risks.